Hi, today I want to walk you through building a simple data pipeline that you can use for basically calling an JSON API and saving it as a CSV file. So I find it extremely useful for different use cases. First, before you build any kind of pipeline, it's worth spending some time getting the actual responses from the API and making sure that the kind of response you get is useful for you, and narrowing as much as possible to the narrowing as much as possible to the fields that you are interested in. So I'll walk you through the example that I used for a open weather API that's essentially getting the current weather for latitude and longitude and saving it in a JSON file. So it is very straightforward. As you'd expect, you call an API with an API key, and you save a JSON, you print a JSON, pre-print JSON, and then you store it into a pandas data frame and log it as a CSV file. So the example you would have is something like this, which have a timestamp, temperature, feels like humidity, cloudiness, sunrise, sunset, description. So very minimal CSV file. One thing that's worth noting, if you just want to write ad hoc script that simply just logs the CSV file, and I think this is a good starting point for building a pipeline, is that make sure that you do the caching. You could do something simple like here, where you could write a pickle file. You just use the decorator around your function, and you save whatever JSON into cache. Like especially when you do testing and you iterate on your code, a lot of extremely useful APIs have very tight limits on them. So it's worthwhile to just have a local copy of the response and iterate on it before you're ready to query this every 10 minutes or so. So great. So now you have a working Python function that can do that extracts the relevant fields for you. So in my case, it's using JSON path and extracting certain things, because obviously not everything is useful, and there's a lot of unnecessary data in the response that you get. So now, how do you make it work with continuously and without having to run your laptop to call these APIs? The solution I will describe is using AWS Lambda function and event bridge schedule to trigger your Lambda function at a certain fixed rate. So we would have to adapt our code a little bit for that, for a Lambda function, mainly to reduce the unnecessary dependencies which are convenient for us to use locally, but are not available in Lambda functions unless you add extra layers. And one more improvement we will do is that we will use Terraform to deploy this Lambda function. So we don't want to, although this is definitely an option, we don't want to go to the UI to configure this Lambda function, but we want to more or less run it with use a Terraform to deploy it. So let's walk through the Lambda function first. We have a bunch of parameters that we will pass to it, mainly the file names. So what our Lambda function does is writing the JSON or CSV file into an S3 bucket, which we can later pull locally and analyze. So here same API call, except we have to switch to URL lib tree instead of requests. And here is our Lambda handler, which is the main entry point. We would try to, before we call the API, we would try to load the CSV from the S3 bucket here, and if we if you can't load it, then we initialize to an empty string, and then we do an API call. An API call essentially returns us all of the JSON. For simplicity, we will log all of the JSON response we get from the API into a file, and we simply append a new line and to the end of it, and we upload this to the S3 bucket. And how do we deploy this code? Well, it is quite straightforward. We define a bunch of variables, like an API key, latitude, longitude. We define the file names. We define the role and policy for executing Lambda function, and we zip the Python code and upload it to a Lambda function, and here we are passing the environment variables to it. And finally, we are going to define the event bridge rule, which will trigger or CloudWatch event rule, which will trigger the Lambda function every 15 minutes. And that's about it. So now we can go and say, assuming we have Terraform set up, we go Lambda and tf apply, and we can see that this everything gets created and deployed. To wait a little bit. Takes a little while. Done. So we have Lambda function running. It's logging to the S3 bucket. So now we can what we can do is the next step. We want to make it easy for us to copy the data from the S3 to locally, so we can analyze. So for this, we will use a makefile. Makefile will create directories, git ignore, and simply use AWS CLI to copy the file locally. So end result, you have a JSON, which is not really proper JSON, but it is not a valid JSON, but it contains a JSON object on each new line, like this. Give me a second. So this S3 is here. So yeah, this is what you get, and you can load this into the next step. You can load it into a Python notebook and extract the JSON, and this is what you have. Then you can normalize certain columns to make this easier to understand with pandas, and yeah, this is the data you have. And the exciting part of it is that now you don't have to run this manually. It runs for you on Lambda when you need to do something very simple and basic, like calling an API at a fixed rate.